So I used to work at this lab.
Yeah.
And they're just a bunch of jokers, a bunch of clowns. So one day they decided...
Scientists or clowns?
Oh, yes.
Really?
Yeah.
Oh, I did not expect that.
A bunch of goofballs. Anyhow, so one day I get this email at work that, you know, my application to, I don't remember what the website it was, had been accepted, and that people would now be voting on how good looking I was.
Nice.
So these guys that I work with uploaded, actually it wasn't even my picture, but they put my name,
Mr.
and people were
Sands.
voting if I was good looking or not.
No, well, no wonder they put the picture on there that wasn't you, because they were afraid you wouldn't get votes.
That's true. I actually come to think of it, I think it was like a picture for the Dodgers. They put that picture of that guy.
Dodgers.
Yeah, it was
a baseball team, right?
Yeah, it is. I lived in Los Angeles. Yeah, you're the sports guy. Huh?
Yeah, actually, I did know that.
Yeah. All right. So anyhow,
they're actually in the playoffs right now.
Oh, they really? I did not. I should know that because my father-in-law is a Dodger junkie. Yeah. But believe it or not, that story actually relates to what we're.
How's that relate?
Doing. Because are you hot or are you not?
Oh, okay. So are you hot?
My wife thinks so. That's all that matters.
Yeah, that's true.
You know?
Cool. All right. Single replacement reactions. We have to decide if the reaction takes place, and if it does, we have to figure out what the products are. Yeah. So we're going to learn how to predict the products of the reaction. Mm-hmm. So let's we just do it. Now, the key thing to understand this, you know, we already talked about this analogy.
We did.
We did that. So basically, the best-looking guy gets the girl.
Right.
That's the key.
Right.
The best-looking guy gets the girl. If he's already got the girl, he
stays.
Keeps the girl.
Yeah. So the and what we mean in the chemistry terms by the best looking guy is the metal that is the highest on the reaction table.
So which guy is most attractive? Now, if you remember at the beginning of this entire unit, we said you need to tape a couple of tables in the back of your comp book. So please get your comp book out now. Open up to that table. The table looks like this. This is called the activity series of metals. And the best looking guy on the block is lithium. Okay?
Ow!
That sounds almost wrong.
En fuego.
Should I back up? Woo!
Nah,
okay.
You're not nearly as hot as lithium.
Yeah, that's true. I'm not.
You're like platinum.
Ooh! Ouch! Ouch! Platinum.
I didn't put you at the clear bottom, but
yeah, close, I guess, huh? Yeah. Okay, I'm that's wild. So the least attractive guy on the block is gold. Now that's kind of weird. Gold's pretty. Yeah. Here I have a gold ring right here. Yeah. It's gold and it's good looking.
Yeah,
right?
but not in terms of chemistry reactivity.
Yeah, in terms of reactivity.
Those anions, they like them some lithium.
Yeah, lithium is kind of the hot guy on the block.
That's right. So I think I'm about a magnesium or so.
Magnesium.
Yeah, I'm about a magnesium.
I was kind of thinking like copper.
Oh, come on.
Well, you put me at platinum for crying out loud. Jeez Louise.
You're old.
I may be old, but
all right.
Be old and good looking.
Let's do some work.
I think we should better work.
All
okay.
Right.
So here we have iron 3 chloride plus lithium.
Okay.
So the first thing we need to ask is, will the reaction occur?
Yes.
Now, the good news about this one is there's no question it's going to happen.
It's lithium.
It's lithium.
Everybody wants to be with lithium.
Lithium is, you know, I used to, another story.
Uh-oh.
Okay, story. All right, my first year teaching, I taught in a school, and I had this boy.
You taught in a school?
I taught in a school, my first year teaching. I know that's wild. In inner city middle school, and I had this young man named Cesar. And Cesar, every girl wanted to date Cesar, and every boy wanted to be Cesar. Mm. And so Cesar is like the lithium. He gets the girl, I don't care who. So iron took the girl to dance, and lithium takes it. So now here's a very important thing we have to do. We have to make a little scratch pad down here, because we have to rebuild the compounds over here. Okay, the common mistake, I'm going to write this down, but do not copy, is they'll say LiCl3 plus Fe. And that is so wrong. Don't ever do that. What we have to do is we have to say, all right, we have to say Fe. We've got 3 players in the game here. Mm-hmm. We've got Fe, Cl, and Li. And we have to figure out what their charges are.
Right.
Now, the iron, it's actually not terribly important what his charge is.
No, because it comes out as plain old iron later on.
Yeah. But chlorine, or chloride actually, we're going to look on the periodic table, and we'll find his charge is -1. Now, we're not going there. And lithium is in column 1, so he is +1. All right, and actually iron, if you look, and actually you can actually go back to this chart here. If you find iron, and he's somewhere on this chart, you'll notice his charge is 3 positive, right? Mm-hmm. So let's go ahead and write that down.
Okay.
So his charge is +3.
And that's what it is in the iron 3 chloride anyhow.
Right. And so what are we going to do is, who's going to get together with who, is it's going to make LiCl.
Well, why didn't you put LiCl3?
Because the charge of the lithium is 1, and the charge of the chloride is -1.
So you're just writing the compounds the way you did in Unit 2 and the way you did in Unit 3. based on the charge.
Yeah, so this is nothing new, but you've got to write the correct formula, and then you'll just say plus Fe.
Now, don't put the charge on iron at this point.
That's right, because he loses the charge.
Right.
He just becomes elemental iron. Like when we saw in the last podcast where Mr. Sam's made the pure silver. It's not silver with the charge, that's just pure silver.
Right, so what happens here is the pure metal on the left gets a charge, and the metal ion on the left loses the charge.
Now, if we write this out, I'll write it out, we can now balance it.
Now we need to balance.
So, yeah, we got 3 chlorides. That's the most complex atom, so I'm going to put a line in front of each, right? Do that kind of thing. And so I'm going to have to put a 3 here. That fixes my chlorine, but it messes up my lithium.
Right.
So I put a 3 here, and that's it right there.
Okay.
That is the balanced chemical equation.
Yeah.
What's going to happen if you put iron 3 chloride with lithium? Now, typically, by the way, it does. This is aqueous. Let's talk about our states. This would be aqueous, and we said this is solid.
Right.
This, since it's in a solution, it's going to stay aqueous.
Right.
And this is iron. That's going to be a solid because when you look in the periodic table, he's a metal.
Yep.
Metals are
So for our purposes, for the single replacement reactions, it's always going to be aqueous and a solid becomes aqueous and a solid.
That is correct.
Unless, unless we make hydrogen.
Yeah. Okay,
We'll
let's
talk
do
about
another
that.
example. Let's say we have potassium phosphite, and calcium.
That is not written correctly, Mr. Bergman.
K3PO3.
Oh, yes, it is.
Yeah,
Never
it is.
mind.
The
I lied.
parentheses.
You're fine.
All right, so we have 3 players here, K, PO3, and Ca. Now, actually, an interesting question we need to ask, who's kind of fighting for who?
Well, the calcium is fighting for the phosphate, and so is the potassium. Is also fighting for the phosphate. So we need to see who is better looking.
So let's go at our table here. Okay. Where's my list? There it is. So potassium is here, and calcium is here. So the better looking one is potassium.
So phosphate is going to go with potassium. Hey, phosphate's already with potassium.
So phosphate already has potassium. So guess what? He stays. This is what we would say.
No
reaction.
So
or we just sometimes just say NR.
No reaction. Very nice. So we don't have to do anything on that one.
So nothing's going to happen because you see potassium is a better looking guy. He's already got the girl. He keeps the girl done.
Yep.
Okay. That's an easy one.
Yeah.
Okay, what about this one, Mr. Sams? Okay, H3PO4 plus calcium.
Okay.
Okay.
So we need to look on the chart.
Okay, so let's look on the chart.
Who's higher, calcium or hydrogen?
There's hydrogen, and then calcium, I believe, is higher.
There it is. So calcium is higher, so phosphate wants to be with calcium.
All right, so we have to play the game here. So who are our players? So we got H, we got PO4, and we got Ca.
Yep.
So actually, this is what it's going to make, right, Mr. Sams? It'll be CaH plus PO4.
No.
Why not?
Because the Ca will never hook up with the H. The cations do not join together. They trade places.
Now, this is important, guys. A mistake I often see is students do exactly what I just did.
Yeah.
Because you have to realize who's competing with whom for the girl. The girl, will, in this case, if we're going to use our analogy, the girl has the negative charge. Phosphate has a charge of -3.
Right.
And hydrogen is +1, and calcium is +2. I've gotten that from the periodic table or my polyion list. That's where I got these numbers. So these are the 3 people. Now, you can't put a positive with a positive because it will never add up to a 0 charge.
Right, because the positive charges, they don't add up to 0 because they repel each other, actually, even.
So I'm going to recopy this. H3PO4 plus Ca, and it's going to make, now we're going to put together, calcium is going to together with phosphate.
Okay.
Now, by the way, I also don't say PO4Ca. I'm going to say Ca in the PO4.
Right.
But I have a charge issue. I have 2 and 3, so that's
we need
6.
to make them 6.
So to make them 6, that becomes
3 calciums.
Ca3 parentheses PO4 parentheses 2 plus
H.
Now, not H. Now, whenever H by itself, it's H2. It's one of those Brinkelhoff
It's
guys.
the in Brinkelhoff.
Yeah. Or in the Magic 7.
Yeah.
All right, that's it.
That's it. We should probably balance
We
it.
should balance that.
Let's
though.
start with the most complicated
Oh, I see a
one.
pretty complex one.
Yeah,
That'd
that
be this
calcium
one.
phosphate's
Boy,
pretty
that's
ugly.
really All right, so I got 3 calcium,
Yep.
so I'm going to put a 3 there.
Okay.
And I got
2
2
phosphates.
phosphates, so if I put a 2 there, and that gives me 6 hydrogens. So put a 3 here. Now, states of matter, we said this was aqueous, and this is solid.
Aqueous. Oh, actually, that's not aqueous.
We'll learn later why. We wouldn't mark you wrong if you said aqueous,
Yeah.
but it's actually a solid. And this is a gas because it's a element by itself.
Yeah.
And it happens to be one we know is a gas.
Yeah.
Why I know this is a solid, we'll talk about that in the next podcast.
Yep.
Yeah. Okay. Okay, good. Now, let's do single replacement reactions, but with
words.
Okay, if I can find the right problem. Here we go. Solid iron reacts with aqueous nickel 2 chloride.
All right. We don't like words. We're chemists.
All right, so first of all, I'm just going to make a little scratch pad here,
Okay.
a little box. This is not part of the answer. I'm just going to write down I have iron, and I have aqueous nickel 2. Now, nickel 2.
Nickel 2, that's Ni with a +2 charge.
Ni with the +2 charge.
The Roman numeral indicates what, Mr. Bergman?
The charge!
Hey, those of you out there who are copying your worksheets, You know how I know when you're copying it? When you don't know what the Roman numeral indicates the charge.
It's the charge.
Yeah.
What's it? It's the charge. Okay. And Cl has a charge of -1 from the periodic table.
Okay.
Now, iron, by the way, is going to have a charge. You look at this table right here. When you find iron, you'll notice his charge is 3 positive. Now, he actually doesn't have a 3 positive charge.
Yet.
It becomes 3 positive. Now, actually, let's first of all decide who's the best looking character here.
Okay.
So we've got iron. I had him circled. And nickel. Okay, so iron is better looking than nickel. He's higher on the chart, right?
Yep.
And so if that's the case,
Iron will go with chloride.
and
So
the
it won't
iron
react.
doesn't have it, so this is going to work. This is going to be a work one. So we're going to say iron Fe,
No charge there because it's just solid iron.
right? Just solid iron. Oh, let's put a little S there.
Put the solid.
Yeah. Plus aqueous nickel 2 chloride, so that'd be NiCl2 because to get the charge to add up to 0, you need to have 2 chlorides, and that's aqueous. Now we're going to trade partners. Now I'm going to look at my box. What are you going to look at, Mr. Sams?
The box.
The box, to determine what the formula. Now we're going to put the iron with the chloride.
Glad I got that right. I didn't know quite what you set me up to say.
And then that is going to be FeCl3 because to get the charges to add up to 0, well, it's FeCl3.
Yeah.
Plus, poor nickel, he gets kicked out.
Yeah.
And there it is. That is the answer, not including the states of matter. This will be an aqueous, and the nickel will be a solid. And then we got to play the charge or the balance equation game. The most complex one, probably this one. This is about the same. But we've got a chlorine problem. We got 3 here and 2 here. When I see a 3 and 2, I think of 6. So I go 2 here, and I go 3 there. And that's going to mess up my iron. 2 irons. So I'm going to go fix on this side, and so that's 2. And this messes up my nickel. So I put a 3 here. So I get back and forth on that balance.
Back and forth.
Okay.
Back and forth.
Back and forth, back and
and
forth.
forth.
Okay, aqueous lithium bromide.
Lithium bromide. Let's make a box. Scratch pad.
Scratch pad box. Lithium is a charge of +1 from the periodic table.
Yeah.
Bromide is -1.
Now, the
Solid
reason lithium
iron.
has a charge is because it's in an ionic compound.
And we have solid iron that has
No
no
charge.
Now, wait a second. Lithium. Something about lithium.
Lithium's hot.
Lithium's like the
Ow!
hottest guy. Lithium's got all the best. So lithium always gets the girl, so to speak, right?
Yep.
Guess what? Lithium bromide. Lithium has the girl.
No
So-
reaction.
So no reaction.
Lithium's already
You
done?
could say LiBr plus Fe, but the answer is no reaction.
reaction.
And this is 1-to-1 because, of course, 1 positive and 1 negative. But no reaction because he's already got the girl. He keeps her.
Yeah.
If he doesn't have her, he gets her.
Yep.
Yeah.
Sorry, iron.
Yeah.
You
That's
are
it.
not
I think
hot.
we'll do one more, Mr. Sams.
Okay.
Aqueous aluminum nitrate. Oh, we got a little polyion. This is good.
Mm.
All right. Box. Start with the box. The box.
Scratch pad.
All right. Aluminum.
Al plus 3.
From the periodic table, he's a charge of 3 positive. Nitrate's a polyion. Look at the back of your
NO3.
table or wherever you've got your
Minus 1 charge.
And barium.
Solid barium, no charge.
All right, so we'll go to barium. All right,
You cannot have an ion that is a solid.
All right, this is the
By
girl has
itself.
the negative charge, and so this is positive 3. So let's look at aluminum and barium on our little chart here. Okay.
Oops.
I gotta find that chart there.
There it is.
All right, so barium is here. Who was the other one?
Aluminum.
Aluminum. Thank you. Aluminium. It's right here. Okay, barium's gonna get the girl.
Yeah, barium.
All right. Does barium have the girl now?
No. Barium's by himself.
Okay, so this is gonna work.
All right.
So I'm gonna write Al NO3 3 because when we get the charge to add up to 0 and put
And
these
that's
together,
aqueous
and that's aqueous
plus Ba
plus Ba.
makes.
Next, now what's the
All
charge of barium?
Barium makes plus 2 ions.
He'll turn into barium plus 2. You can look on your periodic table to
Right.
time that. So I'm going to put the barium with the nitrate. So that's going to make BaNO3 2. And then aluminum gets just aluminum. You lose the
No charge on aluminum now.
Yeah. Very. All right, we're done. Let's
Yeah,
do
wait,
some charges.
You know what? Let's go back.
This is AQ, and this is solid.
Let's go back to our table here. I decided I was a magnesium earlier, right?
Yes.
Remember when I wore my kilt last week?
Yes.
I think that bumped me up to a calcium.
You're wearing a dress, Mr.
It was a
Sams.
kilt.
It was a
It
dress.
was International Day. I wore a kilt.
I think it bumps you down to cobalt. Or
Oh, come on.
something. All right.
You know, my wife actually told me she would never go out in public with me if I was wearing a kilt.
See, I stand
I don't know.
justified.
I think it's pretty.
All right, let's balance
Cal.
this, Mr. For Sam's. We haven't done that yet.
Oh, yeah,
Our
balance.
nitrate has a 3 here and a 2 here, so that's that 6 business.
Yeah.
So I'm going to make them a 6, so that's going to make this a 2 and this a 3. That's going to create an aluminum, 2 aluminum, so I have to put a 2 here. And I got 3 bariums, I have to put a 3 there. So that's the balanced equation. Usually we like to do that in a long line. Probably should have. Sorry. So that's how you do single replacement reactions. You can do lots of these. The key thing, really, guys, is start with the box. check who's the good-looking guy, and once you've got that done, make the reaction.
And wear a kilt and you're better looking.
Not at all. Ouch. No. All right, I'm cutting you off.